Good morning, students. Today I will be demonstrating to you the practical work of a titration in your syllabus. Students, in the class 11th, we have to do the acid and alkali titrations. The concept of the acid and alkali titration, or what do we mean by the titration, was discussed with you in the chapter of chemical and the ionic equilibria. Now, in titration, what is to be done? The acid solution is to be neutralized by alkali solution or vice versa. That is, alkali solution is to be neutralized by the acid solution. Here, the indicator used are either the methyl orange or the indicator used will be the phenolphthalein solution. Now, students, today, this is your experiment number 1 in the class 11th. What you have to do? So, this is practical titration, and this will be your experiment 1. We'll be doing over here the experiment first over here. So, this is experiment 1 and this is acid alkali titrations. What is being given to you? Object or aim of the practical. You have been provided with 2 solutions. C10, it is a solution prepared by dissolving 5.30 gram per liter of a sodium carbonate. So, in the laboratory, whenever you come to the lab, we will be giving you the 2 solutions. One will be the solution of sodium carbonate. This is C10, student. It is a solution of sodium carbonate. How have we prepared? By dissolving 5.30 gram per liter of sodium, 5.30 gram of sodium carbonate in a liter of a solution. Then we have C11. It is a concentrated solution of HCl. Fine. So, C11 is a concentrated solution of HCl. It is a concentrated solution of HCl. Concentrated solution, or I must say, it is a solution of concentrated HCl. C11 is a solution of concentrated HCl. It is a solution of concentrated HCl. Am I clear, student? So, you are provided with the 2 solutions. C10 is a solution of sodium carbonate, which has been prepared by dissolving 5.3 gram per liter. Then C11 is a solution of HCl, the concentration of which is unknown. So, this is basically the unknown solution. Am I clear, student? This is an unknown solution whose strength is not known to us. Now, what do you need to do? First of all, before starting the practical work, you must be aware of the apparatus which are to be used. We use burette, pipette and conical flask and the clamp stand. Burette, pipette and clamp stand. Student, this is a burette. You may see over here. This apparatus is called as a burette. It is marked from 0 to 50. This is a knob to release the solution from the burette. Then this apparatus is called as a pipette. It is marked up to 20 ml capacity. So, there is each mark over here, a circular mark is there. It is of a 20 ml capacity. This is called as a funnel, as we all know. Then this is a conical flask or a titration flask. And then this stand is called as a clamp stand. Am I clear? Then we also have a measuring cylinder. So these are the apparatus which you will be requiring in this experiment. In fact, the measuring cylinder we have used to prepare the solutions, whether the unknown or the known solutions. Now, what is to be done in this practical? Remember, just see the procedure of the practical. Rinse and fill the burette with given dilute HCl solution. So, solution of concentrated HCl has been diluted to the unknown strength. This diluted solution or a dilute solution of concentrated HCl is to be filled in burette. Which apparatus is called as a burette? This is a burette. And this is a C11 solution. And rinse the pipette with sodium carbonate solution. This is pipette. It is to be rinsed with sodium carbonate solution. Am I clear, student? Now, pipette out 20 ml solution of sodium carbonate into clean titration flask, which is also called as conical flask. How do we pipette out? I'll explain it to you now. Just have a glance of this first one. So, pipette out 20 ml solution of sodium carbonate into clean titration flask, and to this add about 2 drops of a methyl orange solution. We all know the solution of sodium carbonate is a solution of strong base and weak acid. So, solution will be basic in nature. Now, to this solution, when we add methyl orange, there will be no change in the color. To add about 2 drops of methyl orange into it. Am I clear? Into the burette we take HCl solution. Into the titration flask we take sodium carbonate solution. To the sodium carbonate solution in the titration flask we add methyl orange. Now run the acid solution C11 from the burette dropwise into the titration flask with a constant shaking till the last drop gives the permanent light pink color. Am I clear? Once you have taken the sodium carbonate solution in the titration flask, to this you have added the methyl orange. Then from the burette you run the HCl solution into this. When the titer value is obtained, that is the end point is obtained. End point will be the point at the that is the point of a neutralization. You will be observing the pink color in the titration flask. So rinse acid solution from the burette dropwise into the conical flask with a constant shaking till the last drop gives a permanent light pink color. Repeat the titration to get at least 2 concordant reading. So we will be repeating the titration to get at least 2 concordant reading. The chemical equation used will be sodium carbonate will react with HCl and will give sodium chloride plus water plus carbon dioxide. You may see over here 1 mole of a sodium carbonate is being neutralized by 2 mole of a HCl solution. Atomic masses are given: sodium 23, carbon 12, oxygen 16, chlorine 35.51 and chlorine 35.5, and HCl will be, hydrogen will be 1. So chlorine will be 35.5. Now, after completing this titration, you have to make certain calculations. What are the calculations? Calculate the molarity of sodium carbonate, which is a C10 solution. Then molarity of hydrochloric acid, which is a C11 solution. Then the strength of C11 solution in gram per liter. Then the concentration of chloride ion, that is C11 solution, and number of chloride ions in C11 solution. So these 5 calculations you have to do once you obtain the end point of a titration. I repeat the calculations. Calculate the molarity of sodium carbonate solution C10, molarity of hydrochloric acid C11, strength of C11 solution in gram per liter, concentration of chloride ion, and the number of moles of chloride ion in the C11 solution. Note, student, any calculation of molarity should be made up to 4 decimal places. Now, any calculation which is not made up to the 4 decimal places, that will not yield you the marks, because as per the board instruction, the calculations are to be made up to 4 decimal places. So, I'll just once again let you get accustomed with the apparatus that we are going to use. This is a burette. Am I clear? Which is in mark from 0 to 50. This is a pipette. It can be of a 20 ml capacity, it can be of the 25 ml capacity. In today's experiment, I will be taking to it as a 25 ml capacity pipette. But when you come to the lab, we may give you the 20 ml capacity pipette. You have to carry out the calculation accordingly. Then these are the beaker. In one of the beaker we have a C10 solution of a sodium carbonate. In another beaker we have a C11 solution of a dilute HCl. Am I clear? Then over here we have a titration flask. Then this is a clamp stand. This is a titration flask. Then this is a clamp stand. Am I clear? And then over here we have a funnel. This is a funnel over here. So now students, I will demonstrate to you the titration, how to conduct a titration. Now students, I will demonstrate to you how to carry out the titration practical. This is a clamp stand. This is a burette. I will clamp the burette in the clamp stand. You can see over here. The burette is being clamped in a clamp stand. Here, in this burette, I will be adding C11 solution. First of all, tighten up the knob from over here so that it does not leak from the bottom, and then through a conical flask, we will add dilute HCl solution into this. The dilute HCl solution is to be added so as to fill the burette completely. We will add the dilute HCl solution into it so as to fill the burette up to 0 mark. Is it clear? You may see it is filled exactly up to the 0 mark. Now, I will pipette out the solution of sodium carbonate. This is C10 solution into the conical flask. This conical flask is already rinsed with the sodium carbonate solution. How to pipette out? This is pipette. You have to suck the solution up to the mark in the pipette over here. So you will be sucking the solution. So you can see I sucked this up into this and slowly brought it to the etched mark over here. This is 25 ml capacity. In the lab, you may be given the 20 ml capacity. So then over here, we'll add the sodium carbonate solution into the conical flask. Is it clear, student? Now, we will conduct the titration. Now, student, into this conical flask, which contains sodium carbonate solution, you add few drops of a methyl orange indicator. When we add few drops of methyl orange indicator, methyl orange is yellow in color or slightly orangish in color. You may see the yellow color over here. Yes. What is the reason why the methyl orange indicator does not show any change in color? Because the sodium carbonate is a solution of a strong base and weak acid, and methyl orange is also basic in nature. So it does not show any color change because the indicator is also basic and the solution was also basic in nature. Now what is to be done? We will put this conical flask below this burette clamped in a clamp stand, and we will add in a dropwise manner the solution of hydrochloric acid into sodium carbonate solution. Hydrochloric acid is acidic in nature. Sodium carbonate is basic in nature. So when we add HCl into sodium carbonate solution, the process of neutralization will take place. As soon as the neutralization occurs, even after that, even a single drop of addition of HCl will make it acidic in color. And with acid, the methyl orange solution will become pink in color. So we'll see and observe when does the slightest of a pink color is observed. In this case, what we do, we will add in a drop-wise manner the solution of HCl into the sodium carbonate solution, in which methyl orange is added, and this is being done with a constant stirring. At a certain point, we will observe the lightest pink color, and when we will observe the lightest pink color, that will indicate the end point of the titration. When the lightest pink color is observed, it will indicate the end point of the titration. Am I clear? So you can see I am adding into this the solution of sodium carbonate, but the pink color is not yet observed. If it is being shaken, then it still remains yellow in color. So we'll again add the sodium carbonate solution into this, and we'll continue adding into this till the slightest pink color is obtained. Till the slightest pink color will be obtained. So if we continue adding this, at a certain point in the titration, we'll observe the slightest of the pink color. You may see the pink color observed over here, and if you look at the titer value, it is coming nearly something about 25. Am I clear, student, over here? So titer value will be 25.3. So this way, the first titer value will be obtained, and I'll make the observation table then. Similarly, so what is the first titer value obtained? This is 25.3. In the same manner, we will carry out the practical again. We will obtain at least. So students, when the persistent pink color is obtained, it means the point of a neutralization has been obtained. That is the end point of the titration, and the indicator shows a slight pink coloration as soon as the solution becomes slightly acidic in nature, and the end point so obtained will be called as the titration. Now, I have demonstrated to you how to obtain the titer value, and I have demonstrated only once. Make sure I have demonstrated only once. But in the laboratory, you have to conduct the same experiment at least thrice. And from those three titer values, at least two must be a concordant values, or two must be the similar reading. And that readings are to be tabulated. I have tried to show you the calculation as by writing on the board. So now I explain to you how to do the calculations. So students, once you complete your practical work, make sure initially the reading of the burette was 0 in the first reading, and titer value as I demonstrated to you came to be 25.3. So what will be the final value? Final minus initial, this will be 25.3. You will repeat the similar practical titration to obtain at least 3 reading. Again the same process will be repeated. We will be having a burette. In the burette we will be taking a HCl solution. In the conical flask we will be taking sodium carbonate solution. To this we will be adding a methyl orange solution, and then in a drop-wise manner we will be adding HCl solution into the sodium carbonate solution. And again you will observe the reading will come to be 25.3. So again the final reading will be 25.3. When you repeat the practical third time, the reading will come out to be equal to 25.4. Now here we have obtained the 3 reading, 25.3, 25.3 and 25.4. In this case, if you observe, these 2 readings are the common readings. So these will become a titer value, and this titer value will be a concordant reading. This titer value in this case will be a concordant reading. Am I clear, student, over here? Concordant means a similar the reading which will be a titer value in this case. Now mention, so you have to make the table to obtain the to represent the concordant value or the titer value. The capacity of pipette used, as I am demonstrating with the 25 ml, titer value will be 25.3 ml. Now, in the calculations, you are asked to calculate the molarity of sodium carbonate solution. So, calculation will be, first will be molarity of sodium carbonate solution. That is a solution of a C10. Formula will be strength upon molecular mass of sodium carbonate. What is the strength given? 5.30 divided by molecular mass of sodium carbonate is 106. So, it will come out to be equal to 0.0500 molar. First question is clear. Now, the second calculation will be molarity of HCl. Formula will be M1V1 of sodium carbonate to M2V2 of HCl will be equal to N1 upon N2. Now, N1 upon N2, 1 mole of sodium carbonate neutralizes 2 mole of HCl. What is the M1 value over here? 0.0500. This is for sodium carbonate. What is the size of the pipette? 25 ml. So, what volume of the sodium carbonate we have taken? 25 ml. M2 is the molarity of HCl we have to calculate. What is the volume of HCl used? It is 25.3 ml, which was the titer value. This will be equal to 1 upon 2. How have I obtained 1 upon 2? From the equation given, 1 mole of sodium carbonate neutralizes 2 mole of HCl. So, molarity of HCl comes to be equal to 0.9881 molar. Both the calculations are clear, student. So, in the first calculation, we have calculated for you the molarity of sodium carbonate solution. In the second calculation, we have calculated the molarity of a HCl solution. Now, the third question which is being asked in this titration is to find out the strength of HCl. What is the formula for strength? Molarity multiplied by molecular mass. What is the molarity coming over here? 0.09881 into molecular mass of HCl will be 36.5 and it will come out to be equal to 3.606 gram per liter. Is it clear, student? So, what will be the strength of HCl? 3.606 gram per liter. So, we have find out the molarity of sodium carbonate, we have find out the molarity of HCl and we have find out the strength of a HCl solution, which will be 3.606 gram per liter. Then the fourth question which is being asked is to find out the concentration of a chloride ion. How to find out the concentration of chloride ion? This is molarity of chloride ions multiplied by mass of a chloride ions. Molarity 0.09881 into 35.5, it will come out to be equal to 3.51 gram per liter. Am I clear, student? So, 4 questions are clear. In the first one, we have find out the molarity of sodium carbonate. In the second, we have find out the molarity of HCl. In the third, we have find out the strength of HCl. In the fourth, we have find out the concentration of a chloride ion. And fifth will be, how will you find out the number of chloride ions? What is the mass of a HCl? 36.5 gram. 36.5 gram of HCl contain how many atoms of chloride ion or how many ions? As per the Avogadro's number, it will be 6.02 into 10 raised to the power 23. If it is 3.606 gram of HCl as calculated over here, it will be 6.02 into 10 raised to the power 23 upon 36.5 into 3.606. It will come out to be equal to 5.95 into 10 raised to the power 22 chloride ions. Am I clear, student? So, this was the first titration in your syllabus, that is sodium carbonate versus HCl. The question related to this has been done with you. There were 5 questions, the calculations of which has been made over here, and the tabular form of a representation of a titer value is also being made. Exactly in the similar manner, you will be writing down it in your notebook. Now, with the same titration, there can be some other calculations. So, in the experiment number 2, the process of a titration will remain same, but the questions will change. So, in the next experiment, I will explain to you how to do those calculations. So, we will be soon discussing the experiment number 2 with you with the same practical work in the next titration most probably. So, I think you must have understood this. That's all for the experiment number 1. Thank you.